Hello, chemistry students. Today we are going to be talking about the next gas law, Charles's law. You're going to be able to, at the end of this video, connect the relationship between temperature and volume, and this will occur at constant pressure. Remember that when we're talking about gas laws, we're always going to complete our calculation in the Kelvin temperature scale. And that's because Kelvin has its temperature scale set for 0 to be absolute 0, which will eliminate any negative numbers in our calculations. If you're given a temperature in degrees Celsius, you will need to convert it into Kelvin using this equation. Charles's law states that the volume of a gas is directly proportional to its Kelvin temperature if the pressure is constant. So again, it is required for the pressure to be constant in order for this law to be true. And this tells you right here that the volume and temperature are directly proportional. So what does directly proportional mean? Directly proportional means that they will move in the same direction. If one is increased, the other will be as well. Okay, so let's complete these sentences together. At constant pressure, there's that constant pressure again, it's very important. At constant pressure, if temperature is increased, volume will increase as well. For the second sentence, at constant pressure, if the temperature is decreased, volume will also decrease. So the mathematical formula that represents this law is V1 over T1 is equal to V2 over T2, where V1 represents the initial volume, T1 represents the initial temperature, and then the gas goes through a change in either volume or temperature, where V2 represents the final volume and T2 represents the final temperature. So here's a visual representation of Charles's law. Again, this occurs at constant pressure, and that is because they're in the same room, so they have the same atmospheric pressure pushing down on them, and then these movable pistons have the same mass, which is sitting on top of the gas. So that covers the constant pressure. And then on the left, you have volume 1 of gas, and then the temperature 1 is room temperature because there's no heat applied to the gas. On the right side, they add heat from the Bunsen burner, so T2 is higher than T1, meaning that V2 also has to be larger than V1. Okay, so let's practice one of these calculations. A balloon is inflated in a room at 24 degrees Celsius and has a volume of 4.00 liters. The balloon is then heated to a temperature of 58 degrees Celsius. What is the new volume if the pressure is constant? The first thing to pick out of this story problem is that the pressure is constant. That clues you in that you can use Charles's law for this calculation. One of the biggest parts of these gas law problems is going to be identifying which equation you need to use. Okay, so just remember that constant pressure means Charles's law. Okay, the next piece to pick out is what are they asking for? They want to know what is the new volume. So they're asking for V2. Now, the next thing you ask yourself is, what do I know? So we should be able to pick out V1, T1, and T2 from the story problem. V1 is equal to 4.00 liters. T1, so the initial temperature is 24 degrees Celsius. We're going to have to add 273.15 in order to get that into a Kelvin temperature. Which is 297.15. Kelvin. And then T2 is equal to 58 degrees Celsius. All right, so now that we have all of our knowns in the right units, we can just plug everything in and finish our calculation. Okay, therefore, I can rewrite this into a form that does not include fractions by cross multiplying. So this times this and V2 times this. So that's what I'm going to rewrite right now. Now, in order to get V2 by itself, we're going to divide both sides by 297.15 Kelvin. This will cancel out entirely, and it will cancel out the Kelvin unit on this side, leaving our final answer in liters. So at this point, I'm going to plug everything into my calculator and then write down what it tells me. So my initial answer only had, so The story problem had only two significant figures in the given temperatures. So I'm going to only be able to use two significant figures in my final answer. So we have 1, 2, and then what does 5 do to 4? They'll actually bump it up. And our final answer is 4.5 liters. All right, let's do one more problem. If a sample of gas occupies 6.80 liters at 325 degrees Celsius, what will be its volume at 25.0 degrees Celsius if the pressure does not change? So again, this clues us in. The pressure does not change, meaning that we're going to use Charles's law. What are they asking for? What will its volume be? So they're asking again for V2. And then we just have to figure out what we know. The initial volume is 6.80 liters. The initial temperature is 325 degrees Celsius. We will need to add 273.15 to get our Kelvin temperature of 598.15 Kelvin. T2 is equal to 25 degrees Celsius. Is equal to 298.15 Kelvin. And now we just plug our answers in and then complete the calculation. Again, I'm going to rewrite this by cross multiplying. To get the final volume by itself, I'll divide both sides of my calculation by 598.15 Kelvin. And this will completely cancel out on this side, cancel out the unit on this side, and then I plug it into my calculator now. So V2 is equal to 3.3894 liters. I began with three significant figures, so my answer can only have three. 1, 2, 3. 9 will bump 8 up. And our final answer is 3.39 liters.